All right. Hello, everyone. We are up to the problem set on naming compounds and writing equations. And the first part of this is saying, using the rules you have learned from naming ionic and covalent compounds, write the following equation in words. And so the analysis for all four of these questions is that we need to have, in order to solve this or be able to do this, we need to be able to know what each of these compounds are. So we need our periodic table, we need our flow chart for naming things, we need our polyatomic ions, and we also need our, whatchamacallit, the prefixes, so that we make sure that we get everything named correctly. So we need all of those documents. So that would be my analysis for these four. And so to begin with, we're going to say number one is magnesium metal reacts with aqueous hydrochloric acid, technically should be, hydro should be on the same, to produce to produce a aqueous magnesium chloride chloride and hydrogen gas. All right. So for naming each of these, well, this is just simply an element, so we read it off the periodic table. And this is hydrochloric acid because it starts with an H, which means it's likely to be an acid. It's a binary acid, so it uses hydro, and then we take the root chlor, add the IC, and so it's hydrochloric acid. Magnesium chloride, this here is a metal and a non-metal. And so we use our type 1 naming. And so we take the name of the metal, so that's magnesium. We take the anion and we add IDE to the end. And so that's magnesium chloride. And then finally, this is one of our diatomic elements, and that is just hydrogen gas. All right, so let's take a look at the next one. For number 2, we have NH3 plus O2 yields NO plus H2O. So NH3, O2, and H2O are all elements, or sorry, all molecules that we need to just know what they are. And then NO is a type 3 because it's two non-metals and it's binary. So we're going to say, so NH3 is ammonia. So ammonia reacts with ammonia reacts with oxygen to produce, and this is, since it's NO, we have one of each, so we don't need the prefix in front of the first one, in front of nitrogen, but we do need it in front of oxygen. So it's going to be nitrogen monoxide. So nitrogen monoxide. Okay, and water. Right. For number 3, we have H2O2 yields water and or decomposes to water and oxygen. And H2O2, if you named it using our there's all sorts of things you might call it. So this one's a little bit tricky. So if you thought it was an acid, then you might call it hydroxyic acid. If you thought, so that's one way that it could have been named, or if you thought it was two nonmetals, then it would be dihydrogen, so dihydrogen dioxide. So that would be an okay answer for this one. And then, but technically this is hydrogen peroxide. So I'm going to put the 3 options, hydrogen peroxide. There are 3 ways you could have named this correctly. Hydrogen peroxide, or a type 3, because it would be 2 nonmetals, and it's 2 hydrogens, so dihydrogen dioxide. And then if you thought it was an acid because you weren't quite sure, then it's a binary acid, and so it would have been hydro, and then we use the anion name, so hydroxyic acid. This doesn't actually exist, but if you named it that way because you thought it was an acid, then that would be, I would have understood why you did that, and you would have been using your flow charts correctly. All right, so then we are next, so this decomposes, or you could say produces, decomposes to water and oxygen. That's number 3. Number 4 is we have a metal and then we have a polyatomic ion. And then we have plus an acid here, a binary acid, gives us a metal and a non-metal. This is a type 1. Actually, I don't know if you can see, so I'm going to move myself over. And we have 2 non-metals here, so this is a type 3. And then we have water. Okay, so we've got calcium, and I would need my thing to know, and I have it over here, so I will grab it. Okay. So if I'm using my polyatomic ions, it's CO3, and so I'm going to look for the things that have carbon, and CO3 is carbonate. So we're going to say this is calcium carbonate, and reacts with hydrochloric acid, to produce. Now, for this is a type 1, so we look at our periodic table tells us that this is calcium, this is chloride. We drop the INE and we add IDE, so to produce calcium, we use just the name of the metal and chloride. Carbon, this is a type 3, CO2, and it's carbon. We don't need the monocarbon, so it's just carbon, but we do need a dioxide. So 2 oxygens, dioxide. And I got the di, remember, from here, from this table. The di means 2, so carbon dioxide. And then our last one, and water. Okay. All right, so those are 1 through 4. For number 5, for this equation, it says to put a circle around the products and a square around the reactants. The analysis for this is that you know that everything on the left hand of the arrow is going to be the reactants, and everything on the right is the product. So it's a circle around the products. So I circle the products and I put a square around the reactants. So that's done. And the analysis again is that you know that your equation is broken down into products and reactants. The reactants go on the left-hand side of the arrow, the products go on the right-hand side of the arrow. All right. Now the last 5 are using the information you know about naming compounds, write the following equations for this reaction, making sure in this case to indicate the states of the compounds. So we're going to, again, we're going to use all of our, our tables and our flow charts. If we might need them, we'll use our periodic table. I'm going to grab it so that I have it. I was going to grab it. There it is. Okay. So here's in the periodic table. And so our first question here is, let me get it out again. All right, our first question here is that sodium metal reacts with water to produce aqueous sodium hydroxide and hydrogen gas. I'm going to put a little line to say that the analysis for these are that, again, I just need all of my appropriate tables and know how to use them. All right, so for number 6, we're going to say sodium, and it says it's metal, so it's in its solid state. Reacts with, so we're going to do a plus for the reacts with water, which is H2O. And since it's called water and not steam or ice, then we know it is in its liquid form. So I'm going to do an L for liquid. And it's going to produce, so that's my arrow, aqueous sodium hydroxide. And so so we know we have sodium, and then hydroxide is one of our polyatomic ions. So I come to this chart and we look for hydroxide. Let's see. Here it is. Here's hydroxide, and it's an OH. So it's sodium hydroxide. So NaOH, and it told us this was aqueous. We're going to do an AQ for that. And then aqueous sodium hydroxide and hydrogen gas. Hydrogen, remember, is always diatomic, so it's H2 and it's gas. All right, so that's number 6. Number 7, methane gas reacts with oxygen gas to produce carbon dioxide gas and steam. So methane gas, methane is one of the ones that you need to memorize, and so that is CH4, and that is a gas. And it reacts with oxygen, so O2. This is our burning equation. This is methane burns in air, and so that's O2 gas to yield to produce carbon dioxide, CO2, which we learned from up here, right? So carbon and then dioxide, and that's because that's a type. What was I going to say? Since it uses prefixes, it's a type 3. And that's a gas. And then it says steam, so it's going to be water. That is a gas. Number 8, dinitrogen tetrahydride. So this is nice. It's telling us that there are 2 nitrogens and there are 4 hydrogens. So dinitrogen tetrahydride combines with chlorine gas. So does it tell us dinitrogen tetrahydride? It doesn't tell us what that is. So we might need to look that up. Combines with chlorine gas. Remember, chlorine is one of our diatomic molecules. So chlorine, so you have to have 2 of them, chlorine gas, and it's going to produce nitrogen gas and hydrochloric acid. So it's producing nitrogen. Remember, it's also diatomic from our list, and hydrochloric acid. And we had lots of hydrochloric acids up the top. So we're just going to look up there and we're going to say, oh, look, here's a 2HCl. So we're going to say plus HCl. And it says that it is, and most acids are aqueous. So the only thing we're not sure about is this dinitrogen tetrahydride. So what I would do in this case is I would pull up my web browser and I would say dinitrogen tetrahydride. Oh, it doesn't even exist. Who knows? Maybe I made it up. I hope I didn't make it up. Oh, good. Maybe I didn't. Tetrahydride, also known as hydrazine, is a covalent compound with the chemical formula N2H4. It is an unstable liquid. So it's a liquid. So we're going to put an L there. All right. Now, number 9 is telling us that we have lithium metal that reacts with nitrogen gas to produce lithium nitride. So we've got lithium metal, which is a solid, reacts with nitrogen gas. So remember, nitrogen is diatomic and it's a gas, and this produces lithium nitride. And so this is a metal and a non-metal. And so if we use our periodic table, we have lithium over here in the first group and nitrogen over here in the 5th group. So how many lithiums do we need for these nitrogens? And so I'm going to do a little Lewis structure here. So lithium is 1 and nitrogen has 5 valence electrons. So 1, 2, 3, 4, 5, and it wants 8. So that means we're going to need 3 lithiums to give up. Each one of them are going to give up their electron to nitrogen. So it's going to be Li3N, so metal and non-metal. And then it tells us that lithium, and it doesn't tell us what lithium nitride is. So again, we're going to go to Google and we're going to say lithium nitride. It says it's an inorganic compound with the chemical formula Li3N. It is the only stable, I'm going to open up, the only stable, go away, only stable alkali metal nitride. It is a reddish pink solid with a high melting point. So it's a solid. Alrighty. And then number 10. So this was number 9. And number 10 it says we have elemental bromine gas can be generated. So that can be generated means the bromine's gonna go over here. The bromine goes over here and it can be generated by reacting sodium bromide. So we've got sodium over here in the first group, bromine over here in the 17th group. So sodium wants to give up one electron, bromine needs one electron, so it's going to be a 1-to-1 relationship there. So sodium bromide, so NaBr, and we're going to react that with elemental chlorine. And it doesn't tell us, okay, elemental bromine gas, so this is a gas. Chlorine is a gas. But sodium bromide, I don't know what it is. So we're going to look it up. Sodium bromide. I'm going to use good old Wikipedia. It is a crystalline solid. So sodium bromide is a solid. Chlorine is a gas. Bromine is a gas. You'll notice that we technically need something else over here. And just out of curiosity, let's look it up. So, we're going to say sodium bromide reacting with chlorine gas gives what? Let's see what Google has to say. When sodium bromide reacts with chlorine gas, it produces sodium chloride and bromine. So technically, we were missing the sodium chloride that were on the left-hand side, and we needed them on the right-hand side, and that's a solid. Okay, great. That is the end of this problem set.